Substitution. Oh, example A. Pamela, when's your birthday? February 12th. Okie doke. And Allison, when's your birthday?
August 18th.
August 18th. Equals. Okay, give me a moment. Okay, so this equals, oh shoot. We're not going to do substitution, just so you know. This is not a good problem to do substitution on. We're going to do addition, we're going to do elimination. Sorry, just realized what I was doing. Alright, so if I'm doing elimination, this is like the examples 3 and 4 in the back. Elimination says you're going to add those two equations together vertically. You're going to add your x's with your x's and your y's with your y's and your constants with your constants once your equal signs are lined up and all that good stuff. But when you do that, what you're really hoping to happen is you're hoping one of your two variables drops out. Either your x's drop out or your y's drop out. Okay? And right now, as is, if I add these x's together, they don't drop out, I get 10x. If I add my y's together, they don't drop out, I get negative 6y. So I'm going to have to do some fixing here, some gerrymandering. Okay, I'm going to play with my coefficients a little bit. And the way to get these two guys to drop out when you add them together is if they have the same coefficient but opposite signs. Okay? So I'm looking at my numbers and I'm looking for nice relationships. You don't always have nice relationships, but here I think we have the x's. 2 and 4. There's a nice, clean, simple relationship between those two. What is it? 2 times 4 gets me 8, right? So what I'm going to do is I'm going to take this top equation and I'm going to multiply it by 4 on both sides, but not just 4. Because if I did regular 4, that's 8x and that's 8x, that don't cancel. But if I do negative 4, then that'll give me negative 8x's that we cancel with my positive 8x's when I add them. Okay? So we distribute our negative 4s and all that stuff. Equals 68 times negative 4, everybody knows is negative 272. I have a nephew named negative 272. No, that'd be awesome. Add them up. X's drop out just like we hoped and dreamed they would. Negative 18y minus 48y is negative 66. Yeah, that's negative 66y, correct? See, that's what I was talking about earlier. You guys don't like talking to me. Yeah, negative 66. And negative 124 minus 272 is obviously negative 396. Okay? So, by adding and canceling the x's, I can solve for y, right? Divide off the negative 66. Okay? And that's part of my answer, but that's not my full answer because we're talking about where lines intersect, right? We're talking about a point where we're expecting x comma y. And so far all I have is the y. I need the x value too.
I have a quick question. Where did the negative 124 come from?
I made it up.
Oh, you started with that?
Yeah.
You changed it. Okay.
I changed it?
I didn't see the negative at first, I'm sorry.
Yeah. I mean, that's what the calculator told me to put. Alright, so we get y equals 6. And if I want to find my x, yeah, I take this and I take either one of the two originals, whichever x looks easier to solve for. Being top, it doesn't matter because the calculator's going to do all the arithmetic for you, right? But sure, top. 2x plus 12 times 6 equals positive 68. equals -4, so x equals -2. So, no, 6. -2, 6 is my answer. That's the point where those two lines would intersect. Alright, that's elimination. So you'll work examples 3 and 4 sort of maybe kind of like that. Addition goes like this. Not addition. What's the other one? Substitution. See why I don't want to teach today? Substitution. The only time you would ever bother doing substitution is if you had 1x or 1y somewhere. Okay? So that's why I didn't want to do substitution here. I wouldn't have been able to solve for one of these x's or y's in like one step or less and get something fraction free. That's the ideal situation. So, example B. What are we going to do? We're going to do 4x minus y equals something. 33. And we're going to do x plus 9y equals 110. Alright? Now, the way substitution works is you're going to solve for one of those x's or y's. And this is why it's important to try to get into one step first. Like I usually don't bother unless I can look at it and do it in my head. Okay? So I see I've got like a minus 1y here, and maybe I can solve for that y in 1 or 2 steps, but I have 1x right here, which I can very easily solve for in my head. What would it require to get this x by itself? Just subtract the 9y's over. So this equals, or this becomes 110 minus 9y. And where those two lines intersect, they have the same x and the same y at the same time, correct? So whatever x equals here, isn't it going to be the same thing here in the other equation, if it's the same x? So I'm going to take this, and I'm going to plug it in for that x right there. I'm substituting a 110 minus 9y for my x. That's what I call the substitution. So I do 4 times 110 minus 9y minus another y equals 33. And then I'll be able to solve for y. And then once I have my y, I do the same thing. I go back and I find my x. Okay, we'll finish it. 440 minus 36y minus another y equals 33. So negative 37y equals negative 407. And then we divide by 37. We divide by negative 37. And what do we get? Oh, good. I was hoping it was 11. This is the number I made out at least.